Welcome back. In this video, we're going to talk about taking the derivatives of logarithms. So we have one basic rule that we really need to know, and then all of the other rules that I might show you in this video, they can be inferred using our previous knowledge, if that makes sense. So the main thing that we are going to save and store is that the derivative with respect to x of a log base a, and that base can be any number as long as it's positive and not 1. So log base a of x, what that equals is 1 over x and then times the natural log of that base, regardless of what the base is. All right, we're dividing by natural log of the base. So let's look at this in action. For example, we might have ddx of log base 2 of x. Well, according to the rule up above, we have 1 over x, and that would be times natural log of 2 in the base. Or we could have ddx of the log of x. Now, in this case, there's no base written, and when we have log with no base written, we know that's the common log, or base 10. So this is the same as ddx of log base 10 of x. So knowing that what that means, then we can use our property for the derivative of a logarithm as stated in the first line, and that would be 1 over x times the natural log of 10. So let's look at one other example here, because we end up deriving something that we use quite a lot. In this situation, ddx of ln of x. So ln is the natural log. And what we want to remember is that a natural log is base e. So this is the same as writing log base e of x. Well, applying our rule, that would be 1 over x times natural log of e. However, we know that when the base, natural log is base e, and the argument are the same, that logarithm is going to equal 1. So our answer here could be 1 over x. All right, so I'm going to erase this and just put this one other rule up above. And like I said, we can derive it. We only need to know the first rule that I've written here. But the second rule, we use it so much, and it's pretty simple. We tend to remember this one as well. So this would just be 1 over x. And so as I said, dividing by the natural log of e is just 1. So it goes away. So these are two rules that you want to make sure that you can use. And in my opinion, knowing the first one is enough, because when we do this one, the natural log of e is going to go away. All right, so we also have to consider the chain rule. All right, so it's not always that my argument, which is what I'm taking the logarithm of, is going to be just x. A lot of the times we're going to have an expression or a function in there. So let's think about this. And if we already know our chain rule, this isn't a new rule that we necessarily need to remember. We just say, hey, we're going to apply our chain rule. And the phrase that I like to say to myself when I'm thinking about the chain rule is the derivative of the outside times the derivative of the inside. So if I had log base a of some function, we'll call it g of x. So g of x represents what's on the inside. Well, applying our rule, that would be 1 over the argument, and the argument was g of x, times natural log of that base a. So that's the derivative of the outside, but what we need to remember is we also must include times the derivative of the inside. And multiplying those fractions, this times the derivative of the inside just slides over into the numerator. So this is a rule we can either remember or derive using our chain rule. And I have one other way we can write it, considering it could have been a natural log. So d dx of the natural log of some function. So d dx of the natural log, that's going to be 1 over the argument, g of x. But of course, we need to multiply by the derivative of that argument, which was inside the parentheses in the argument of the logarithm. So we end up with this, and multiplying to simplify that, we end up with g prime of x over g of x. So these two rules aren't new. The two up above are, and now we're applying the chain rule to them. So let's do a natural log or regular log derivative where we have to use the chain rule. In this example, we're going to find the derivative of y equals the natural log of 3 over x. So what we would do here, this is natural log. Our rule that we know is that dy dx is going to be the derivative of the argument. I'll write that out. Derivative of the argument over the argument. All right, so let's look at this. Using a little bit of algebra, I don't like the way that argument has a divide by x in there. But I know with my algebra skills that I can rearrange that and write that as 3x to the negative 1. So that means if I were to take my derivative, I would find that the derivative of y with respect to my independent variable x is the derivative of the argument, which is 3x to the negative 1, over the argument, 3x to the negative 1. So now I just need to take the derivative in the numerator. That would become negative 3x to the negative 2 over, I have 3x to the negative 1. So I use the power rule in my numerator. Negative 1 comes out in front. That's where I get my negative 3. Subtract 1 from negative 1, I get negative 2. Looking at simplifying this, times 3 in the numerator and denominator, that cancels to 1. So I have negative, this is negative, I have x to the negative 2, and if we're dividing, we would subtract exponents, so that is minus negative 1. And minus negative 1 is plus 1. So I have negative 2 plus 1 in my exponent, or negative x to the negative 1. Which we can simplify a little further. That would be 1 over x negative. So my derivative of y with respect to x is given right here. So I just want to expand on our thoughts here, right? Same function. We have y equals the natural log of 3 over x. If we use properties of logarithms before we start this, properties of logarithms, the log of a quotient, that means I would say natural log of 3 minus natural log of x. So just using algebra, I have ln 3 minus ln x. In this situation, if I were to take the derivative again, the derivative of y with respect to x. The derivative of ln x, that's a constant. Ln x is a number. I can type that in my calculator. And we know the derivative of a constant is 0. So then I have minus the derivative of natural log of x. And that's a very basic rule we know, 1 over x. So you can see this is the same. dy dx equals negative 1 over x. And I had way less calculus to use if I knew how to do my algebra at the onset. So let me just do one more example, a basic logarithm derivative using the chain rule, although it's not going to be base e. So we have y equals, I'll say log base 5 of 6x cubed. If I wanted to find the derivative of this, well, this is the derivative of a basic logarithm. But notice, my argument, I have an expression other than x. So that means I'm going to use the chain rule. And because my base is not e in the denominator, I'm going to end up with a divide by natural log of the base, right? So the derivative of y with respect to x is 1 over that argument, 6x cubed. Since my base is 5, I write times natural log of my base, 5. And then we need to take the derivative of the argument, so times d dx of 6x cubed. d dx of 6x cubed, that's going to be 18x squared, and that's going to slide right into my numerators. So I have dy dx equals 18x squared over 6x cubed times the natural log of 5. This, of course, I can simplify. X squared is going to reduce that down to 1. 18 over 6 will turn that guy into 3. The derivative of y with respect to x is 3 over x ln 5. And that's my final answer. So make sure you practice this a little bit before we move on to the next video.